Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at the Nvidia keynote that took place at Computex just about a week ago. So this would be Computex 2023 by Jensen and Huang. And so there's a lot to unpack here. I mean, I'll leave you a link below if you want to watch the full video. It's 2.5 hours. There's a lot in it, but I'm going to condense this down for you. And we're going to talk about all the points, but we're going to make it very short. So, yeah, that's the idea. That's the thought and the idea anyway. So let's let Jensen explain what is the problem we're trying to solve today.
I told you several things. I told you that we are going through two simultaneous computing industry transition, accelerated computing and generative AI. This form of computing is not like the traditional general purpose computing. It is full stack. It is data center scale because the data center is the computer. And it is domain specific. For every domain that you want to go into, every industry you go into, you need to have the software stack. And if you have the software stack, then the utility, the utilization of your machine, the utilization of your computer will be high.
So let's talk for a minute about what that stack might look like. Nvidia calls their stack Magnum IO. And as you can see from the graph here, it encompasses a lot of architecture, a lot of packages in order to make this up. So I guess one of the things that it's great to have all this software, but what is it good for? One of the things that Nvidia has built with this is a way to make games more interactive. That's kind of always been the dream, right? To be able to have a conversation with the game and then make it do things along with some prescribed courses of action, because obviously you have quests that you need to complete, but to let things kind of unfold in a natural way of conversing with another avatar. And to do that, Nvidia has something called the Avatar Computing Engine, or ACE. And so let's take a look at that.
Everything is real time.
Hey Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
None of that conversation was scripted. We gave that AI, this Gen AI character, a backstory. His story about his ramen shop and the story of this game. And all you have to do is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for all kinds of characters to be generated. They're all domain. They have their own domain knowledge. You can customize it, so everybody's game's different. And look how wonderfully beautiful they are and natural they are.
I mean, that is impressive, right? But what else can it do? What else can we use this for? Let's take a look at a couple of simulations that Nvidia showed during Computex. obviously that is running in real time. In order to do that, you're going to need some pretty powerful hardware in order to be able to keep up with that. So let's take a look at what hardware that Nvidia is suggesting for this application.
H100 is in full production, manufactured by companies all over Taiwan, used in clouds everywhere, enterprises everywhere. 35,000 components on that system board. 8 Hopper GPUs. Let me show it to you. All right, this, I would lift this, but I still have the rest of the keynote I would like to give. This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect. This computer is $200,000. And as you know, it replaces an entire room of other computers. So this, I know it's a very, very expensive computer. It's the world's single most expensive computer that you can say, the more you buy, the more you save. This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100 with the world's first computer that has a transformer engine in it. The performance is utterly incredible. Hopper's in full production.
So the more you buy, the more you save. That's a new one. So we had a saying too when I worked for Burroughs. This was regarding our largest competitor at the time, which was you can buy better, but you can't pay more. So, I mean, I'm not necessarily saying that about Nvidia, but we are clearly moving the pendulum from distributed computing over into the centralized vein heavily. Cloud kind of took it halfway, and this is really pushing it all the rest of the way. I'll have more to say at the end, but let's take a look at this, more about this Grace Hopper super chip, and how does it scale? How do you make this thing scale up? And let's take a look.
Meanwhile, this engine that's going to be used for AI factories will be scaled out using Grace Hopper, the engine that we created for the era of generative AI. We also took Grace Hopper and realized that we can extend, on the one hand, the performance, but we also have to extend the fabric so that we can make larger models trainable. And we took Grace Hopper, connected to 256 node NVLink, and created the largest GPU in the world, DGX GH200. Look at this. This is Grace Hopper. This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated processor, accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. And so the GPU can reference the memory, the CPU can reference the memory, and any unnecessary copying back and forth could be avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer's on here. All of the uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. Incredible levels of performance. This took us several years to build, and I'm so excited about it. And I'll show you some of the things that we're going to do with it. Okay, so 4 petaflops transformer engine, 72 CPU cores. They're connected together by a high-speed chip-to-chip link, 900 gigabytes per second. And so the local memory, 96 gigabytes of HBM3 memory, is augmented by LP DDR memory. Across this link, across a very, very large and high-speed cache. So this computer is like none other the world's ever seen. Now, let me show you some of its performance. So I'm comparing here on 3 different applications. And this is a very important application. If you've never heard of it, be sure to look into it. It's called vector database. There will be other AI factories in the future, but this is really the first one. And the last one is large language model inference. 65 gigabytes. 65 gigabytes is a 65 billion parameters is a fairly large language model. And you can see that on a CPU it's just not possible. The CPU is simply not possible. With Grace Hopper, with Hopper on an x86, it's faster, but notice it's memory limited. You could, of course, take this 400 gigabytes and cut it up into a whole bunch of small pieces, shard it, and distribute it across more GPUs, But in the case of Grace Hopper, Grace Hopper has more memory on this one module than all of these. Does that make sense? And so as a result, you don't have to break the data into so many pieces. Of course, the amount of computation of this is higher, but this is so much easier to use. And if you want to scale out large language models, if you want to scale out vector databases, if you want to scale out deep learning recommender systems, this is the way to do it. This is so easy to use. Plug this into your data center, and you can scale out AI. Okay? So this is the reason why we built Grace Hopper. We're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access. And they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. We will, of course, build these systems as products. And so if you would like to have an AI supercomputer, we would, of course, come and install it in your company. We also share the blueprints of this supercomputer with all of our cloud suppliers, so that our cloud partners, so that they can integrate it into their networks and into their infrastructure. And we will also build it inside our company for us to do research ourselves and do development. So this is the DGX GH200. It is one giant GPU. Lastly, we would like to extend AI to the world's heavy industries, the largest industries in the world. So far, our industry that all of us have been part of, has been a small part of the world's total industry. For the very first time, the work that we're doing can engage every single industry. And we do that by automating factories, automating robots, and today we even announced our first robotics full reference stack, the Nova Orin.
So I wanted to spend a few minutes. First of all, let's talk about the TOPS 500 list that just came out just a week or so ago, almost a week ago. So the top runner is the Frontier, and that is an AMD Opteron 3rd Gen. That's an EPYC processor. And it also uses the MI250X GPU. So that one just passed the exaflop barrier last year in June of 2022. The TOPS 500 list is published again, usually June, then November. So November was exactly the same score as what they saw in June of 2022. But this year, they improved that a little bit. So you can see it's 1,194 petaflops, which is one exaflop, 1.194 exaflops. So that's pretty impressive for what we've got. So I thought probably that some of the other things that were in the PDF is, and you can go look this up on the TOPS 500 list here for yourself. But you can see Intel had quite a dominance from about 2015 all the way through 2019, and then they began losing market share to AMD, which is the blue at the bottom there. So AMD is whittling away a little bit at the processors that are being used in the HPC list. So what about ARM? Well, I think the ARM is being counted as proprietary, and that shows up about 2020, and you start seeing they're starting to creep up too, and take some of the CPU count away from Intel, maybe some from AMD as well, not sure. But as far as the accelerators and coprocessors are concerned, that space is clearly owned by Nvidia, as you can see by this, and they have pretty much owned that space since about, well, maybe 2016, 2017 or so, and they are pretty much saturated all of the HPC machines with their devices. So what does that mean for Nvidia? Well, that means that they have to go look elsewhere beyond the normal high-performance computing group that would be putting these machines into hyperscale machines in order to work on problems like weather, and also they do some things with medical and also military applications as well. Yeah, where do you go from up, right? So I think this is my take. Nvidia is stretching out and trying to embrace some of the other industries, and particularly that are in need of artificial intelligence support. So for their processors, which for the most part are going to take hyperscale computers to do that, as Nvidia well knows. So, but what about the industry where we see these? So we have vendor, research industry, classified, government, and academic. You can see that clearly the shift has, some of the vendors kind of declined for a while, up until about 2014. Then they had a brief peak, and then they declined again up until about 2019, and then they're starting to go up. Those probably are AI servers. Don't know that. They don't really expose that kind of information here, but research has been pretty steady. There's been some ups and downs in it, but it looks to me to be fairly constant over the last decade at least. However, you'll see where Nvidia is targeting in their Computex demo, they're targeting industry, and industry has been shrinking a little bit. So that's an interesting choice that they're going after here. So yeah. And I don't know what some of the reasons are for that, but they don't tell you that. Here's kind of what my concerns are. So first of all, on the plus side, I think what Nvidia is doing is impressive. It's interesting to see that not only have they provided tools through the Magnum IO, and also they also have databases that you can use for various markets that are downloadable from their website. So, and that's a plus too, because that saves a lot of time in machine learning tasks, particularly and they also have a lot of tools for AI transform, and also AI, of course, the generative AI, which is very popular today, ChatGPT being one of those. But there's always a but, right? Here's what I'm thinking. So if you're a startup and you're wanting to get into the AI space, well, all of a sudden the barrier to entry has gone from here to because of the cost to get involved with it. Now, granted, you could rent time off of cloud services, and Jensen talked about Meta and also Azure Cloud and also Google Cloud as being participants with Nvidia to host the Hopper and chipset. So along with their infrastructure that scales out and up to be able to handle large problem spaces. If I was starting up, you're probably looking at, you're looking at tens of millions of dollars to get started. Even if you're leasing the time off of a cloud service, yeah, they're paying that rate, so they're going to pass that cost per hour along to you. The second thing is that I'm not convinced by Jensen's demo that they're really paying all that much attention to the boundary around AI. So I think it was about a decade ago, one of the large cloud providers did some experimenting with writing code with AI, and so they let it go for, I don't know, it might have been 3 to 6 months. And then they came back and they looked at the code that the AI system had written, and they couldn't understand it. They couldn't figure out what it was doing. Obviously, it had been working, or they would have been alerted sooner, but they just wanted to see what state the code was in, and they did not understand it. So, Jensen was talking about, well, yes, you need to shepherd the AI processes, but if you're pushing this into industry, which is profit motivated, darn good and well that a lot of those tasks are going to go to the wayside in favor of new development, right? That's the way corporate environments work. So I'm a little concerned that we don't have boundaries around AI to prevent it from, as he was talking about, going into hallucinations. But that's not all of the problem. The other part of the problem is, all technology can be used for good. It can be used for bad as well. And there's no protection boundaries around what AI is doing. So that's a bit of a concern. And since marketing is pushing this, they also are profit motivated. And so they're not going to care. They just want the sale. I think the other thing is power. Power, and even Jensen alluded to this. A lot of the major data centers today are constrained by the maximum amount of power draw that their data centers are allowed. And so they have a cap, and they cannot exceed those power usages. Here you're going to take this technology, which is clearly a great power user, and stuff it into a data center which is already being used to solve classical data processing problems, and try to tell it, to somehow, can I move some of the workloads off of my traditional processing environments onto AI or not? So yeah, this was decades ago, but we actually tried some of this in order to see if it was feasible to do this mix and have some of the applications in the core systems like, general ledger, AR, inventory control, transportation, logistics, all of those kinds of things or supply chain. As you might expect, hyperscale computers that are in the HPC realm, and Nvidia can paint whatever color they want onto the side of the box and say, well, it's really an AI processor, but it's really a supercomputer. Those workloads are parallel. And most of our traditional applications are not written for that space. So you have a pretty high cost to adapt those applications over to parallel processing if you want to move workloads across to those machines. Well, I can tell you that we tried some of that. It didn't run very well, partly because we weren't optimized for it, partly because parallel processing is very hard to do, and partly because the workloads just didn't fit a vectorized model. Those are some of my comments about this. So I'm just gonna close out here, and I hope you enjoyed this video today. I would like to take this opportunity to thank my supporters both on Patreon and members for the channel. Without you, none of this is possible, and I sure do appreciate your help. As for the rest of you, thanks for getting this far in the video and watching it. I appreciate that as well. So with that, that's all I had for today. Please let me know in the comments below what you think about all of this. Hope to see you next time. Bye for now.